you're also having some side reactions, and depending on what you use to help the water conduct the electricity, because pure water is not a great conductor. So this baking soda is what we chose to use. You can use table salt, especially the non-iodized kind, so you don't make bad byproducts. You can use Epsom salt, which is magnesium sulfate. Pretty much any ionic compound that will allow the water to conduct electricity can be used to essentially complete the circuit and allow electricity to flow through the solution so that you can separate the water. You do get some side reactions, but essentially what we're making is hydrogen gas and oxygen gas. So we're decomposing water, and this is generally called electrolysis of water. Question number 2 says, when you perform a blazing split test on hydrogen gas, and of course we haven't done that yet, but one of these test tubes, the one that's over the big end or negative end of the battery, is collecting the hydrogen gas, and the one over the small end is collecting oxygen gas. And you all know that hydrogen blows up, like, Hindenburg hydrogen boom. So when we collect a tiny amount, we get a little tiny explosion, which won't hurt you, I promise, because you'll be holding it in your hand when it happens. So don't worry. But it's completely not going to hurt you. So we'll do a blazing split test on your hydrogen test tube, and that's going to give you a formation reaction. So the answer to blank in number 2 is formation. When you perform a blazing split test on hydrogen gas, you're going to do a formation reaction. So just undoing all the hard work that you guys have done with this battery, and you're going to take hydrogen gas plus oxygen from the air, and what will you make? Water. So we'll just remake the water that we decomposed with the battery when we do the blazing split test. So in number 2 it says the blazing split test will cause formation of water, and then it says write the balanced chemical equation for this. So we're testing the hydrogen gas, and it'll use oxygen from the air, and it'll make water. Now, what's wrong with my equation for the formation of water? Okay, Micah.
Well, there's a few things. First of all, hydrogen and oxygen, since they're homonuclear diatomic, should have a subscript 2.
Beautiful.
Also, it's unbalanced, so you would have to put a 2 in front of the H2 and the O, and yeah, you can just put it.
Okay. So this would be the balanced chemical equation for the formation of water. Formation, of course, are 2 elements in the homonuclear diatomics, all 8 of them, in their elemental form are diatomic. So the formation of water is hydrogen, and we know it's a gas. You guys can see it right there in your test tubes. Plus oxygen, this comes from the air, not the other test tube when we do that. Gives us water, which, depending on the temperature, is probably going to be a gas, because it's going to be hot. It'll probably condense quickly, but it'll be formed as a gas, and then the room temperature will probably cause it to condense. So that's an example of a formation reaction that you guys are going to see once everybody collects enough hydrogen. And as a key point, if your test tube